Okay, great. Hello, everybody. Thanks for having us here, and we'll get the session started. So today we'll talk about AI and machine learning and its impact and use cases for fintech. So first off, let's introduce the speakers, and then Keenan, would you like to give your introduction first?
Yeah, sure. Hey, everybody. Thanks for dialing in. I'm Keenan Freyberg, a product manager at Kensho. I work closely with our machine learning team's applied research and development group. By way of a little background for Kensho, back in 2018, we were acquired by S&P Global, the company behind benchmarks like the S&P 500, and a leading provider of credit ratings, analytics, and data for both capital and commodity markets worldwide. Kensho serves now as S&P's innovation hub, and we focus on using state-of-the-art machine learning techniques to design and apply products geared toward improving the handling of unstructured data, all to help our clients make decisions with conviction.
Great, thanks, Keenan. So a bit about myself. I do software product management here at NVIDIA. So AI software, and my main focus, there are two products I'm working on. One of them is actually focused on conversation AI, which is called Jarvis. And then the other is for video streaming, that's called Maxine. And then Keenan and us, we had a very positive collaboration and look into how AI can be used to help with fintech use case. So this session, we're going to take a deep dive and having Keenan to share with us the experience and best practice, etc. And we'll look a little bit in the end, closing with the technology trend in the conversation AI. So with that, we'll get started. I think Keenan already touched on the background of Kensho. Maybe you can share more about, the use case and technology and how you go actually now being acquired by S&P. So how the journey goes.
Yeah, sure. So Kensho has traditionally focused on natural language processing. But most recently, as part of the collaboration that you touched on, we've been working on Scribe, which is a speech recognition tool specifically optimized for the business and finance communities. Scribe is a bit unique and complements our other capabilities in that we're generating the text that we've traditionally focused on analyzing. But kind of broader strokes on the Kensho playbook is post-acquisition, we've been fortunately able to retain the agility of a startup, but now we're able to tap into the resources of a multinational, including large, extremely high quality data sets. So really just always looking for opportunities to bring together the parent company's data with our technical talent. And when successful, the synergy between the two enables us to both design and apply technology that doesn't just result in incremental improvements to their processes, but rather allows us to sort of reimagine the processes altogether.
Yeah, that's great. So it sounds like there are two main components. One is the data set, which is very important, information source to tap into, but you need a good set of technology to be able to really massively scalably to process this amount of data set, right?
So, yeah, absolutely.
Yeah. So kind of curious, I know that so Keenan and us, we met during GTC GPU Technology Conference last year, and they did a great presentation about the partnership between NVIDIA and how our technology actually helped with the solutions they're building for S&P. Would you like to share a bit more on how did you find us out and how that technology has helped to build out the solution stack that you're working on?
Yeah, sure. So we started working together as part of Scribe, and like any other AI-enabled capability, broadly speaking, three kind of ingredients for Scribe and other AIs: algorithms, data, and compute. NVIDIA, of course, is a category leader in compute, and we'd been using your hardware to train our models for some time. But we really started working more closely together with your research team when we reached out with questions regarding one of your open source models. So more in the algorithm space. Jasper specifically, just another speech recognizer. We were shopping around for different options for one of our subcomponent models that comprises the intent pipeline that is Scribe. And we're trying to learn more about Jasper, which, a deep time delay neural network comprised of all these blocks of one-dimensional convolutional layers. So Gerard Kutsko, Kensho's head of AI research, had reached out, I believe, with questions about like hyperparameter tuning. Just started speaking with your NEMO team, or your neural modules team, which is a toolkit for building conversational AI applications, and realized that we were both working on speech recognition, but we had data but lacked compute, and NVIDIA had compute but lacked data. So we ultimately brokered a non-commercial data sharing agreement that has enabled us to collaborate on and advance ASR together, which has been tremendously useful from the Kensho side, certainly.
Yeah, could you say more? Is it that you exchange the data and also we helped out with the compute side, so that way it's accelerate the development flow?
Yeah, all the above. So I think there are just some natural fits in terms of filling out each other's strengths and weaknesses in terms of data and compute, and just respective knowledge in the algorithm space. So our corpus is enormous, somewhere between 100 and 150,000 hours of audio and corresponding text. That's between 10 to 15 years of data if played end to end at 1x speed. So previously training our models on this homegrown corpus would have taken us around 6 months previously, had we provisioned resources from AWS or just used a few cards that we bought from you guys. But now we're able to train our models, our acoustic model at least, which again is one of the many subcomponent models in the end-to-end pipeline, in less than 8 hours. And that's been tremendously helpful for picking up important words and phrases that enter the lexicon in a sudden, seemingly sudden amount of time. So I think like coronavirus, COVID-19, other words like remdesivir are great examples of that. Nowhere to be found in our training corpus before March, but then suddenly it had been mentioned over 9,000 times in the month of March, the drop of a hat. So the partnership, both in terms of, the access to compute and your access to data, as well as just kind of kicking around ideas on model architecture, has been really valuable to us, certainly.
Yeah, thanks for sharing. So just one quick note, I think for the audience that you're dialing in right now, you can actually feel free to use the chat window. If you have questions, please feel free to type in and we'll address them either through the flow or in the end of the chat. So yeah, so just for some background, right? I think training acoustic model, doing automatic speech transcription, there are a lot of domain-specific words, especially in the financial domain. And then really the trick to getting high accuracy around very specific domain is through the training against a large corpus. So the models that Keenan is using is actually being able to grasp all those domain-specific jargon or acronym, even like, for example, specific dollar signs or versus euro, simply through actually speech transcription model training. And then this won't be done possible if we don't, on both of the hand things, if we lack the data set or if we lack the compute, because it's going to take very long time to finish the compute. And where NVIDIA position is that we're not a data company, but on the other hand, we accelerate compute using GPUs, and on top of that, we build software and also model architecture. One of the models that Keenan mentioned called Jasper is actually one of our research models, and we share that with publicly open source, so anyone can just use it to train against their own data set. Yeah, so I touch upon some of the challenges with acoustic model training, especially for domain-specific data. Just curious to see, before you look at Jasper, have you tried out other approaches, and how are they comparing to, let's say, deep learning-based methods?
Yeah, great question. First we were doing this manually, so I think it's actually good to start there. S&P catalogs thousands and thousands of corporate events and corresponding metadata every day, buybacks, guidance, defaults, board meetings, and over 150 other event types that could move a company's securities prices. 40,000 of those events per year are actually audio derived, meaning you could dial into or listen to them. So things like earnings calls, management presentations, acquisition calls, events of those nature. So S&P has a team of hundreds of analysts who have been creating transcripts of these events for the past decade, and molding this unstructured data into a format that kind of helps our clients parse through it easily, rather than dialing into and listening to them all end to end, and just quickly find the information that they really need to make whatever decisions they need to. And we have extremely strict service level agreements with these clients, a data quality program that pays out $50 actually for every error that clients do find in those transcripts. So as you can imagine, producing a 99% accurate transcript for 40,000 calls a year is a very human intensive process. So, we weren't looking to enter this space of conversational AI, but it did start there, Alex. Yeah, we were shopping around for some of the other options. Not only tried other providers for sort of more black box solutions, but also many of the different frameworks that are out there, and it just had a really good experience with working with the Nemo team and using your toolkit.
Yeah, thanks. I appreciate that. So, let's just put things in context. I think the alternative solutions on the market these days are one of the popular source would be going to the cloud service providers. They have their own APIs, and then you can make you call an API call and then send in your data, and you'll get the transcript back. It's very convenient. It's very handy that you don't need any setup. However, on the other side of things is that there's little room for customization, especially when it comes to domain-specific jargons. And then actually, as a matter of fact, a lot of companies actually, they do own significant amount of data that they would actually want to leverage and understand how can they better make use of that. And then the secret sauce to getting the high accuracy is actually through training on those data sets, right? And that's what eventually that actually help to increase the accuracy, but you also add a lot of the post-processing pipeline as well.
Yeah, certainly it's a combination of all those factors. I mean, the out of the box solutions that you touched on, we're actually increasing our turnaround time. Our analysts had really honed their manual process to the point where it was quite efficient. Now we're saving over 1.25 hours per call by sort of marrying that triumvirate of data algorithms and compute.
Yeah, that's really amazing.
Yeah, but the using a homegrown data set really enables us to optimize the service to handle the complexities of our use case. So in our situation, that's messy, real world financial audio. So getting challenging things like numbers, currencies, tickers, industry specific jargon that you mentioned, even product names like pharmaceutical drugs. Is quite challenging, as well as just more general nuances of spoken language and being able to represent those how we want. So things like mumbling, stuttering, filler words like as well as hesitation, or even things like self-correction. And being able to use your own training data, you can not only sort of keep a pulse on that a little bit better, but also keep an eye on potential biases in the training data, and more quickly sniff out the sources of features or bugs, depending who you ask, on things like non-standard words, where the written and spoken representations of an utterance are different. So things like 31 cents, should that be 3 different words, 31 cents, or $0.31? Or one of my favorites is currency imputation, actually, where if a speaker does not explicitly say what currency they're referring to, the service will actually impute what they're saying. So again, feature or bug, depending who you're asking. But having access to the entirety of our training corpus and knowing how it was created and seeing the style guide that drives those decisions helps us sniff out why their interesting model behaviors might be happening.
Yeah, that's actually pretty magical to see that the model corrects different, accuracy, different currency symbols. I remember that very clearly. I was like, wow, that's really cool. Okay, so yeah, so a bit of maybe could you describe? I'm just curious to see how this whole technology put into the, everything in the perspective, the whole workflow. How is that put into use in the? Could you give an example of like how does it help with real world problem solving versus the status quo before?
Yeah, certainly. So, at Kensho, we, like I mentioned, look for opportunities to bring together the parent company's data with our technical talent. And that's really a good heuristic for somewhere where there's already a need. If there's a lot of manual effort to create the data set, there's typically a process that can be, streamlined around that effort. So in this case, for Scribe, just as one example for among the suite of other projects we're working on, I'd mentioned we cover something like 40,000 earnings calls, management presentations, and acquisition calls per year. Within a half year of building Scribe, we were processing 99% of those calls, which is around 40,000 per year, saving 1.25 hours per call relative to the fully manual process. And instead of removing seats, have really reallocated that effort to expand our coverage. We're now processing events from 1,500 companies that neither we nor any of our competitors were dialing into previously, which just gives a bigger investment universe for our clients, which is great. And then my favorite part of this process is instead of relegating this capability and others to just internal cost optimization, we sort of change tack and productize the solution, Scribe and others, once we've achieved internal traction, and work with external clients to take on their needs as well. So S&P has unique needs, but they're not that unique, and we believe that the other clients would face similar issues. So I really enjoy working with our new external clients on not only using this internally, but making sure that they can harness our technology as well.
Yeah, that's really cool. So actually, there's not only you enhance the productivity and reduce the cost, but you can also create a lot more value-added services, both internally and externally.
Mm-hmm.
Yeah.
Right.
Yeah, just to maybe fast forward a little bit, how do you see, the conversation AI space, and there are, new models coming in like GPT-3, text to speech is also another very active field to generate synthetic voice, let alone, all the speech transcription getting more and more accurate, but at the same time getting smaller model footprint. So how from like a Kensho technology perspective, like looking to incorporate the trend of conversation AI and to enhance your service and solution offering?
Yeah, a lot of exciting
I'm sure.
spaces to explore for us. I think within the Scribe universe, I'm particularly excited about a few use cases. I previously worked in consulting for a Fintech consultancy, essentially. I'm really bullish on the idea of sitcom compliance. Taking processes where human analysts previously monitored something like 0.001% of calls with 99% accuracy, sort of turning that on its head and monitoring 100% of calls with closer to 90% accuracy. I think that's a really promising approach and something that we're exploring internally at S&P. Additionally, IVR, interactive voice response. I thought Erica at BAML was exciting, and expect to see more of that. And then just more generally in terms of processes, something we think a lot about at Kensho is getting real about the extent to which automation can really retool a process. It seems that our clients seem to fall in one of two buckets, one being where they're not automating their processes at all, and the other being that they're banking on 100% accuracy. So I think there's a real opportunity for folks to kind of sail into reality and sort of tailor different versions of their services to their clients' specific accuracy, latency, and security needs, and just having different versions that could touch on all three of those in whatever combination they may come in. Because what do you do when state of the art isn't perfect?
Yeah.
And that's exciting. But yeah, what do you think? I mean, would be curious to hear your thoughts as well, of course.
Yeah, indeed. Thanks. I think it's fascinating to see how different requirements coming for accuracy, and also new features that will be required by the clients, and also be able to provide technology to support them. So on our side, so where NVIDIA sits really that we're looking to, from research to engineering, and eventually spin out that as our product to support many end users' requirements. And then for us, really the main goal is to accelerate the compute for developers, for companies who would like to, use their own data set, and then looking for the tools that can actually help them to tap the most and get the most out of their data sets. So we're constantly looking to kind of what kind of the tooling, what kind of the software that we can provide. So Nemo, as Keenan mentioned earlier on, we're adding on the roadmap, we're adding on a lot of new models to do not only speech transcription. Now we're able to do speaker identification, and then for example abstractive summarization, so where you have like a paragraph of maybe the meeting notes and be able to summarize that in particular format. There's also like what we call hot word keyword detection. So we're actually fusing together a lot of the upstream research models and then streamline the process and then put them into production, and also open source that to the developers so they can actually use that. And to us is that we understand the capability, the power of GPUs, and we optimize all of those models for that, so that you can actually innovate and accelerate the time to market as soon as you possibly can. That's for the training. So once you have a lot of data, now on the inference side, we also understand that research models are great and they're really sort of the manifestation of all the research innovation. In our company, we're looking to how to support your production needs, because really that's eventually how do you manage different compute resources from the software and both software and hardware perspective. So we provide a platform like Jarvis is the platform for inference pipeline. So once you train the model and then once you need to use them every time, and we provide you the inference engine so that you don't have to write the whole pipeline in scratch, and we have optimized the whole performance for you. For example, conversation AI, if you look into speech transcription, like a typical use case, it will be a smart virtual assistant. If you ask the virtual assistant a question, and then for the virtual assistant to process and then reply to you in the synthetic voice, that typical loop, including the network latency, shouldn't be more than 200 milliseconds, which is long enough for the human to actually detect any sort of significant delay. And then what we took that problem as simply a compute problem. How can we fully accelerate the pipeline so that we can reduce the time to respond for under a constraint of 200 milliseconds? Right. So this is one example of how we're looking to accelerate and enable the whole ecosystem is through really providing that accelerated compute platform and technology. And then upcoming, text to speech, there are a lot more exciting things. So we have research goes into voice cloning. So for example, one voice coming in and the other voice coming out. And all those are really just take data, annotate well, and then technology such as deep learning models to actually being able to map your input voice into another setting. So I think we're getting close to the ending. So if I may, I would like to end that with a demo. And before that, I'd like to thank Keenan and the organizer for us to have this opportunity to share what's the solutions and then what Kensho is working on. So for that, I will play a demo with all of you. Just give me a sec to bring this up. Okay. Let me share my screen. Okay. The demonstration we call Misty, our first interactive 3D. Here you see the network latency delay. Well, it's while it's streaming, so I can just voice over so that we can save time. So this Misty is a end-to-end voice-based virtual assistant. And this is actually a keynote demo that looks like we have some technical issues, so I will stop sharing. So I can voice over. So it's a virtual assistant. It's a speech-based virtual assistant. And then we created that back in May. The point is to demonstrate end-to-end speech pipeline and then being able to address the very specific domain. And in this case, we use the weather domain. On top of that, we also added on real-time rendering. So as you know that a lot of companies are thinking about customer services, leverage digital assistant, and then how can they do that in a very personal, relatable fashion. So that's where we added on the real-time rendering. So unfortunately, the screen sharing seems to have a little bit technical issues. So I'm happy to share this link with the audience afterwards. With that, I think we are on top of the hour. And thanks again for dialing in. And if you have any questions, please feel free to share.
All right, thanks, Alex.
Yeah, thank you so much, Keenan. It's great to catch up with you again. Looks like
yeah. Likewise.
All right. Thanks, everyone. Have a wonderful day. Thanks for having us. Bye.